Good morning, folks. We are moving into another section of Chapter 10. We are surprisingly running low on sections left this year, so we are going to keep going at the slower pace, which I don't think anybody's really complaining about. I haven't been receiving any complaints, so hopefully this is working for everybody. 10.3 deals with geometric sequences in the series. We already talked a lot about arithmetic sequences in series. This is just another specialized case of them. In fact, you can probably remember a good amount of this from Algebra 2. So I'm going to take a different approach with this in the fact that I'm going to try and rely a little bit on some familiarity from Algebra 2. So we're going to jump right into some examples and introduce definitions that way. So a good geometric sequence is one that has something called a common ratio. So the task here is I want the 10th term of the sequence. If we know what the second term is, which is 24, and we know the common ratio is 1/2. Well, the common ratio is simply something that is multiplied every single time to produce the next term. So for example, the second term is 24. I'm going to multiply by 1/2 our common ratio, and I know then the third term would be 12. And then the next term times 1/2 would be 6, and then 3. And I could keep doing that as many times as I needed, but it can be very tedious. So let's go through the algebra of it. So this little box right here is the general form of the arithmetic sequence, or the general term, or the nth term. So this is, I believe it's also called the explicit formula. So general term or explicit formula. So an equals a1, that's your first term, times r to the n minus 1. R is the common ratio. N represents what term place you're looking for. So if I want the 20th term, I'm going to plug in 20 for n. So let's just use a little bit of information that was given to us to figure out some of the missing information. So for example, we know the second term is 24, so we can plug that in for an and set n as 2. We also have the given ratio is 1/2. So we're just plugging in everything we know and solving for a1 to be 48. Once we have a1 and we have r, we have the full explicit formula for this geometric sequence. So once you have that, just plug in 10 for n and we can get the 10th term. So most often you're going to see it's going to be either really, really large numbers or really, really small numbers if we keep multiplying by something. So we're going to look for exact answers. So do not panic, but I would like a 3/32, not whatever that decimal would look like. I want an exact fraction when appropriate. So let's move on to another example. So this time again, I'm looking for an explicit formula for a geometric sequence, and we have some information. This time we know the second term is 80 and the fourth term is 5. So we're going to do this two different ways, and then I'm going to wrap up the video with that. So again, I'm going to utilize the explicit formula, the a1 times r to the power of n minus 1. So we have two things here. We know the second term is 80, and we know the fourth term is 5. So I can plug 80 in for an with the equation n equals 2 on the other side. Or I can plug in 5 for an with n equals 4 on the other side. So both of these equations are part of the sequence, but we don't know what r is, and we don't know what the first term a1 is. But we do have two equations with two unknowns. So this is actually going to turn into kind of a system of equations that we then need to set up a substitution here. So the first thing you want to do is, of course, simplify. The two r values can be reduced to simpler exponents. Okay? After that, typically one of these is going to be very easy to isolate a variable for. So in the first equation, a1 r to the first, I'm just going to solve for a1 in that case. So I'm going to divide the r to the left side. And what I'm going to do now is I'm going to take that this a1 equals 80 over r. I'm going to plug it into this lower equation down here for A1 into the second equation. So now we have an equation that only has one variable r, which if I'm multiplying r cubed over r, that's of course r squared. I can then divide the 80 over, I get 1/16. The square root of that, because I'm solving for r, is 1/4. So we now have, excuse me, r. We can plug that back in and get a1 pretty quickly, is 320. And once you have A1 and you have R, you have the pieces of your formula that you're asked for. So there's my explicit formula. Now, this was a lot of work, and this is a very reliable method for whatever terms and information are going to be given to us. This is a always going to work method. I'm going to answer the same question in a more intuitive fashion, but it can be challenging depending on the sequence you're given. So again, we knew the second term was 80. We knew the fourth term was 5. Okay? They're not that far apart. They're only 2 place values apart from one another in this sequence of numbers. So for example, to go from the second to the fourth term, we divided by 16, which means you had to multiply by something twice. So we divided, if I'm instead of saying divided by 16, that's kind of like saying I divided by 4 and then divided by 4 again, right? So that means in order to get the very next term, you're going to divide by 4 just once, aka multiply by 1/4. Well, there's your R value right there. So you can almost intuitively find out that R is 1/4. You can then work backwards to the left in the sequence and multiply by 4. Once you have that, you have your first term and you have the R value. Now again, this works because there's only one missing term in between the two givens. If instead of the second term and the fourth term, let's pretend I had the second term and like the 12th term, that's really difficult to do this kind of intuition method. So I would stick to the system of equations side of things there. I'm going to cut it off here for today. Before we move any further into section 10.3, we're going to spend at least another day or two on this because we have the time. So take a look at the homework, get started on it, and of course, as always, reach out with questions. Be good, be safe, have an excellent day.